just
forward to the
told
quick.
people you
Oh,
wouldn't be here
Yeah.
okay.
on the basis of that, which email you were talking about.
Yeah, well, I figured I wouldn't be here tomorrow morning, but I figured tonight I'd be here. So anyway, go take it away, Dave.
Okay. Well, welcome to the March 24th, 2026 session of Tapper and HamSci technical session. My name is Dave, KV0S, and this week, let's see, I remotely attended Nathaniel's conference. It came across well, and it it uh, it was very interesting. The talks and the variety and the quality were all excellent, so I was quite pleased. Congratulations, Nathaniel, on that. Next, I want to go ahead and start a roll call, and let's see. Here we go. So next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Let's see. It has been a busy week as always. So yes, last weekend, which is just over a week ago, we had the HamSci workshop at the ARRL in Connecticut, and like Dave said, I was incredibly happy with it. I thought the ARRL did a fantastic job doing all the local logistics and organizing, and I had a really wonderful time at the workshop. And really all of the presenters and the people who participated were just wonderful. So it was great. I'm very busy this week, working on a grant proposal that's due next week, and everything else going on. One general announcement for everyone. The University of Scranton, as I have said, is getting rid of their Zoom license in June. And so our plan is to migrate to Teams. And I've asked Gary and McKeaton help us do this. So I've had the university set up a HamSci Teams team within the University of Scranton that I can give people that we sign up through the university can actually gain like even administrative access to that team. So I gave Gary McKeaton AFAA administrative access to that, and he is supposed to be starting to play around with the teams settings and trying to test things out. So sometime within the next couple of months, we're going to try that migration. So hopefully it will go smoothly, but we'll let you know. Back to that.
Very good. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Oh, hello. Um, if you let me find the right window. Um, yes, hello. Um, I have been, I really enjoyed the workshop. I thought it was the best one ever. And I really enjoyed getting to go to that. Um, Beyond that, I have been more or less beating my brains out trying to configure machines here at home. I have an endless list of things that need doing, but none of them are really all that fascinating, I don't think, to this group unless you're interested in knowing about my battles with AMD and configuring their newer architectures. But that's about it for me. You take care.
Okay. Next on the list is Dave H, W6OQ. Go ahead.
Good evening, everyone. Not much happening this week radio-wise. Did have to rewire some outlets in my new bathroom because the electrician couldn't figure it out how to put a separate outlet on the load side of a GFCI. I don't know what's up with that. Anyway, that's what I was doing.
Okay. Well, next on the list we have Dave, WB9YIG. Go ahead, Dave.
Oh, good evening, folks. I've been up to my ears in repeater repair. Uh, Actually had something happen to me for the first time in a long time, working on a 80 amp Astron supply and had a capacitor blow up on my workbench. That was exciting, but we got that sorted out and got the amplifier working. So I got a 250-watt amp sitting on the bench now, ready to go in tomorrow. So that's all here. Back to the net.
So I trust that no hams were hurt in the excitement, right?
No, nothing. Nothing happened. I've been repairing blown caps and stuff. It's just the first one I've actually had blow up my face. Uh, it was a nice little mushroom cloud come up.
Oh, okay.
It was impressive, So, but swapped it out and got a replacement for it and what have you. So everybody's happy now.
Very good. Next on the list is David McGaw in 1HAC. Go ahead, David.
Oh, good evening, everyone on the net. Yeah, that having capacitors explode always is a fun time. Uh, uh, I've had a few confetti um, extravagances over the years. But yeah, well, a couple of things of excitement this week. One is we got a couple inches of I don't know what to call it. Somewhere between rain and snow, and I think we call it kitchen sink. But then the struggle I'm having is an interesting one. We've got a Yaesu satellite Altaz rotator that I can't get to behave. It's tracking, it's working, but I can't get it to calibrate. It scale factor is off. I have an aftermarket interface, which may be part of the problem, but HamLib interfaces to it just fine, but I cannot get it to take straight keyboard commands. So if anyone has any experience with these guys, let me know. But that's where I'm struggling with trying to get our ground station to track the satellite. But and that the other thing is excitement this week, if you can call it that, is that working on getting a good UHF power amplifier. We need something on the order of, well, greater than 100 watts, something less than a kilowatt. And Bob W1XP was trying to resurrect one of his old amps, but power supply wasn't behaving on him. And now he's off to a, believe it or not, high school reunion. But we do have a line on some TV amplifiers, 400-watt amplifiers for good money that I'm going to try to incorporate. Montana, who's our primary, has been using those because they blew up their tube amp and haven't been able to repair it. But as for HamSCI, got a couple of talks on the cinema movie project that are getting lined up. Of course, one being Hamvention. I'd be happy to be talking about that. Hopefully, we get a lot of interest in it. At the workshop, it certainly, as Nathaniel called it, the ultimate talk. But it did come off. I was actually impressed how many of us did stick around to the end. So I think that says a lot for the content and enthusiasm. And boy, it was fun being able to hang out at W1AW and see the labs and all that. But thank you everyone who set that up. So I guess that's enough out of me. Back to Net.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. As others mentioned, the HamSCI workshop definitely, I would say, is the best one yet. A big thank you to the ARRL, Bob Interbitson, Nathaniel, and all of the presenters. It was great to see everybody there, those who attended. It was a really fun time. I really enjoyed it. A lot of good information and ideas and passion and enthusiasm exchanged at the workshop, and that's what's important. So it was a really nice time. So I just want to give my thanks to everybody involved and that made it a really good time. I've been working on the um, I went back to the end panels that I've been working on for my VLF interface box, and there was something that I wanted to bring up in the general session. So it has been said from like multiple people um, that there's a possibility of using the RX888 or whatever for VLF reception. But what I wanted to get was an understanding of the capability of um, the system now. Not only with the RX888, but the this pulse per second timing injection. Um, I just want to understand it because I want to compare it to what's being done in VLFRX tools. So I'm hoping to get some more insight on that later in the general discussion. That's all I have. Back to the net.
Very good. And next on the list is Paul, WB6 CXC. Go ahead, Paul.
Yeah, good evening, everybody. Yeah, of course, I had a great time at the HamSCI. I yeah, thank you for giving me a spot to talk about the time sync stuff and just meet a whole lot of really interesting people. Again, I'm always come away from that kind of heartened. We were getting young, you know, kids involved in this stuff and interested and enthusiastic. And like I said before, the fact that it's in radio, ham radio, whatever is almost irrelevant. I mean, the fact that they're doing anything with their hands and their minds is incredibly important. So, Nathaniel, thank you for setting that up. Other than that, well, I'm now back up in Friday Harbor. I did my commute from Occidental after HamSCI was over, and I'm back up here now, getting. I'm within I'm within a few hundred words of having my document finished for the 888 redesign. I'm waiting for some more time sync stuff to come in from China that I can put together and test. I sent one of the time sync boxes out to Gwen um, today. I sent it out, and but we got to make sure. Um, Rob, I was mentioning was to Scott that we need to make sure that Gwen has the software he's going to need in order to make any use of it as soon as we can put something together. And I dug out one of my Trimble Thunderbolt GPSs because I've been playing the GPS and clock accuracy, GPS deal accuracy, and pulse per second accuracy. So got that up and running and doing some comparisons just to make sure I understand how the various units behave. So that's about it. Back to net.
Okay. Next on the list is Phil, KA9Q. Go ahead, Phil.
Hey guys, not too much to report. I'm in Baltimore, Maryland, and heading to Vancouver tomorrow for ARDC annual meeting. So I guess I'll pass on the rest of it for now.
Okay. Um, Next on the list is Scott Newell in 5TNL. Go ahead.
Hey, heading to work this weekend, so I don't really have anything to report. Back to that.
Okay. And then next on the list is Tom in 5EG. Go ahead, Tom. Microphone.
Oh, I'm not so accurate with the mouse anymore. Lots of work on FPGAs for the last 3 weeks, and I think I've got a scheme now finally that will work for the quad receiver design. Got all the timing constraints put in, and it's passing all those. So learning a lot. In another 100 years or so, I'll be a qualified FPGA designer, but it'll take a while. Back to the group.
Isn't that the way it is for all of us?
Hey, it's fun to learn.
Yes. The tragedy is when you stop trying. And next on the list is Rob Robinette, AI6VN.
Let's see. I've been working on upgrading Whisper Demon sites, and many of which with our 888s, and um, trying to get them registered and uploading to the PSWS server. So um, I'm turning my attention now much more to client stuff now that the server stuff is up and running for some weeks. And the let's see, we got Tom WA2TP running. He has two 888s, and I think he is contributing now to PSWS. So he should he's a he's our number 2 spotter in the world. So his reports should be really high quality to the WWV reports. Let's see. I think thanks to yeoman efforts on the part of Michael, we got DP0 GVN back online. I think that I don't think we know what really went wrong with it or why it's back, but it reappeared and seems to be running once again, and an extraordinarily useful site because of its location. I think it reports again to PSWS. I almost need somebody that would tell me when there's problems with these, because I don't have time to chase down problems. If somebody tells me a site is not reporting, then I can go look at it.
Well, I think those are some of, I'm not that's going to happen right away, but Christina and Bill Engelke have been working very hard on the charrette to make improvements to the central control system and central website. And so, those sorts of dashboards to keep track of that stuff are on their list of implementation items.
Yeah, I actually think it already has what is really needed. I mean,
Yeah.
if you check a box on your station's page, it will send you an email to
Yeah.
tell you that your site isn't reporting.
Yeah.
But there's nobody at the other end of those emails. I mean, I'm on the ones at the stations that I put up.
When you say, you mean nobody on the server side or nobody at the
No, nobody pays attention to the emails or doesn't check the box to get the emails.
Right.
So I think that it would be I think that the reporting mechanism is in place, but there's no one person responsible to say, is our network of receivers fully functional? What percent, 90, what is the set of receivers, and are they all available?
Well, that does fall under like what Christina's title is, which is like chief operations scientist. But so I think eventually that's something that she's going to be paying attention to, but she's been paying more attention to the charrette right now.
Okay, well, in any
but,
case,
but with all of that said, the sooner we can get that sort of thing resolved, the better. So if there is something we can help with, or if we want to try to recruit a new person to make that their job, like a volunteer position, we can try to find someone.
Well, you have Emma and other people. I don't know
Yeah.
who you have in your
Yeah.
stable.
So right now Emma is working. I told her main job right now is to just get personal space, whether finish up the documentation, and she's working with Gary to get the Daisy 2 sites, set up and sent out the door for this summer. So she's working on that.
Well, good. Well, one of them, I don't know the status. Did you that young man who has the one from Johns Hopkins and he that where his it just
Yeah,
disappeared? Did
Jim
you?
Conroy.
I don't know. It was he had a young man, a high school student, was actually uh, working with the device under the mentorship of someone.
Yes, under Jim Conroy.
Okay,
So
well,
so
that was
Emma did get a new one sent out to them this week, I believe.
okay. Well, I was a little bit engaged, and then I heard nothing. So
Yeah.
I would like
Yeah.
like to know that there's someone has taken ownership of that.
Yeah, they emailed us last week and they said that they really figured out that it was a hardware issue. So they sent their old one back to us, and we can send that somewhere else. But then we shipped a new one out to them, so that's in the mail right now.
Okay, well, it'd be good to verify the one that came back for them is truly broken,
Okay.
and to understand why it broke. That's the
Can we send that to someone?
yeah, you could, the first thing to do is have Emma plug it into the lab and into a server and give me the IP address and I can log into it and take a look at it. So
Okay,
that'd be
we
the
can do
first thing.
that.
Yeah. Okay, so if you would do that, and tell her that that if she's going to be the kind of the first the front between out to the sites with your Daisy sites. If they fail, they should send them to her, and she can plug them in to, send a replacement, plug them in, and let me know. I can look at them, and then we can decide what to do. I mean, it's not
Yeah.
clear whether these are truly broken, whether it's intermittency or incompatibility. I think part of the problem is that the system as it's designed currently already has a lot of interconnection, a lot
Yeah.
of cabling that is and resulting ground loops that make it fragile.
Hmm.
And so hopefully in the as we evolve our own design that we can address some of these issues because the more cables you have and more devices from different manufacturers with SMA cables and connectors between them, the more points of failure are in the system.
Yeah.
And we want these things to be like refrigerator. My goal is they should be like refrigerators. You plug them in, they run. You know, and
Yeah.
and if you lose power, they come back up on their own, just the way they were, and recover. And if
Yeah.
that doesn't happen, I want to know why. Anyway, I would like
Yeah.
to help make that happen. Some of it's software. I designed the software to do that, but there's other aspects. The hardware aspects are ones that others are going to have to address. So, but
Yeah, I will definitely have her plug that in and contact you once it arrives. So it's probably going to come in this week.
okay. Okay, well, that's all that comes to mind at the moment. Well, I have other discussions. I want to talk about time of flight, and I would like to get Scott's code plugged in, so it's WD record is available. That's what we need so that uh, Gwen can use his, and we can start having the option of saying there is a time of flight or even better, have it automatically detect, whisper demon automatically detect the presence, the time of flight, the time sync data, and calibrate to it. So that's so. But I need it to be part of K9Q regular build. And I don't know that there's any reason not to do that. I'd like to hear a reason, a goal to get that incorporated so that we don't have special builds and special software running at different sites.
Okay, I'll try and work on that this week.
You need to you and Phil. It would be a lot of trouble to try to integrate WD record with PCM record. I don't need that. It's fine to have a separate WD record. It's
Understood. Yeah.
okay. Gwen waxed rhapsodic this morning about the system. He's just really happy with it. And he just wants data from more places. And as a final aside, we could talk about it later. We need a way to record not just so that the wave files start at microsecond zero. We also need a way to record the correlation spectra, if you will, not just one number, but the whole series of numbers of how correlation works. Because for Glenn's analysis, he wants not looking just at the strongest signal, that happens, whatever the path is, the time of flight of the strongest signal. He wants to see all the other peaks
Right.
and kind of. So I think to do that, we need to have a place to store that data. I can put it into the extended spot records on the Whisper Demon site. Um, and that's what I'm proposing to do, but I'll talk about that in more detail later.
Do we know what kind of time frame we're looking at saving that correlation result over? 10 milliseconds, 30 milliseconds, 100 milliseconds?
Well, that's a good question. It looks like okay. Again, I don't mean to dominate the conversation here. So if there's others in line, we can talk about this in general. Is there anybody else in line, Dave?
No, we've been through everybody here. Oh, Clint just showed up. We should give him a chance.
Okay.
Clint?
Okay. Yeah, I'm trying to get cameras working here, but I've been busy with ham related projects that I can't talk about, but glad to be here. And I'm always interested in what's going on with the time of flight. So back to you.
Very good. So we've talked to everybody, I think, that's on the list. So
okay,
we're open for general discussion.
Okay. So let's continue my discussion with Scott. I talked with well, there are two elements to this. Michael, who can't be with us tonight, has said that in his project, he determined that it was optimal to make the IQ recordings at 20 kilosamples rather than the 16 kilosamples we're using now. I infer that was because that 20 kilosamples were some integer multiple of the tones that he was looking at in the WWV signals. And as a result, he didn't have to do interpolation or rate conversions on the wave file recordings. Or he got better ones, better.
20 or 24?
I thought it was 20, but I could be wrong.
I think 24 works out better, but I haven't looked at his code recently. I should investigate.
Okay, well, he will be back, I guess, in another week or so or two, and we can determine what the optimal rate is. Of course, the cost is to that is more disk space for the raw recordings. But it's just RAM. So it gets discarded. So I don't think I don't see any reason not to choose a bit rate that is optimal.
How much
For
does
that.
that affect Whisper Demon?
Doesn't affect us at all. I mean, we
Well,
really,
it looks for the number of samples in the file when it dumps them if they're corrupt. And
okay, yeah, okay, well, yeah. If we change the sample rate, obviously I have to, I have a test to see how many samples are in the file, and of course there'll be more samples in the file, so that test will have a different number.
what
But
about the 1 minute of silence to fill in the missing files? Is that at 10 hertz or is that at full rate?
that's done at full rate. So yes, you got that. You're right on, Scott. All of the side issues, but those are those are all, I can fix all that in half an hour. So it's not a
Well,
big deal.
I've been thinking about this experiment because Michael had said he was running at a different sample rate. And yeah, so I was going to switch over my personal system and see what happened. And I've been meaning to ask you what all's liable to break when I do that. And
Yeah, the
those are the
number of
only two I could come up with.
yeah, I could pretty easily put in a config file flag uh, to change the sample rates, uh, yeah, Whisper Daemon. We'll find the sample rate and from that derive what it expects the file size to be, and the number of samples in the recorded files and so on. So it does, when it processes the files, um, it won't make much difference because it'll just take the SOX will take the full rate files and decimate them down to 10 hertz. So but so architecturally it doesn't change anything, but yeah, there are a few stages where there's some tests and of file size and bit rates and so on that will need to become at least probably ideally configurable. So I'll put that on my to-do list. But the other one is to get your the results of your correlation. Um, so once you determine um, the exact absolute time, then there would be some correlation coefficients, right? You determine right now. Scott. You come up with a single peak, which tells you what the time of flight was for the strongest signal.
Right.
But there must be you must be
There
going
is.
through a comparison process where you
Yep.
go and that process is I intuit that it's one sample. Take one, go at sample offset 0, sample offset 1, calculate the correlation, and just go through a series of them until you find the peak, right?
Yeah, it pulls out the peak in the first 10, 30, 100 milliseconds, whatever the range is.
Yes. Well, it sounds like I don't know what the longest time of flight we might look for. It seems like it's in the range of maybe 30 milliseconds. I mean, uh, but, um, maybe we could even make it a configurable value. So, because down at DP0, you probably want to look a lot longer than you would at WWV0. You don't need to look that far there. You know that the main path and any multipaths are probably within a few milliseconds of time zero. But at other sites, it could be deeper. And I think Scott, may have suggested, and I just confirmed that there's you can have a column, ClickHouse column that is an array, and we could
Right.
have
The other thing I looked at, I've never done it. I'm not very SQL conversant, but most SQL engines also support blobs, binary large object. So my plan was to start there with SQLite and then dump it over to you however you want it. And I don't know if the array makes more sense or the blob makes more sense. That probably is a question more for Gwen.
he was talking about the array, an array, and
Okay.
so I mean, if you're looking at the samples, right, there's 10 samples per second, right?
No. At
I'm
24
sorry.
kilohertz, I
No, we're
just
looking
told
at the
Michael,
wrong. You're talking about the 10 kilosamples or whatever. So,
I just looked at Michael's GitHub. It's 24 kilohertz, 24
okay.
kilosamples. And at 30 milliseconds, that would be 720 samples
Okay. Well,
per minute.
that sounds perfectly reasonable. And I mean, the correlation values would probably be what, 16-bit ints?
They're floats now, but they could be converted and scaled to whatever you want.
Well, this does seem a place where floats would be expensive. Storing an array of floats. Um, I mean, they'll look a lot more like random noise, so they'll not be very compressible compared to ints. Um, I don't know.
That, again, may be a question for Gwen more than me.
Well, he thought ints. When I talked to him this morning, he thought a 16-bit int value
But
would give him enough range. I mean, you want to scale the whole thing so that you take the peak and make that a value of you know s- uh, uh, 2 to the
Well, do
16.
you?
I
Or does
I
the
would
pig
recommend, excuse
Yeah.
me, but I'd recommend talking to Michael about this because he had some strong opinions about whether an int or a float.
Okay.
So,
Yeah, great.
but I can't give you
Great.
the exact argument. I mean, he gave it to me once, but he worked on it all the time, and I just heard it casually, so I can't reiterate it. But
I mean, one thing I was wondering when thinking about this, was is there any way to represent in reasonable amounts of data the nature of the signal itself that might preserve a degree of other signals like backscatter? For example, a set of coefficients, a small set of coefficients that would give some detail. Like if you had some equal backscatter stuff, that's valuable information that you're losing. I mean, if you're not preserving the original incident signal. I mean, Gwen would love to have the original files, obviously, to mess with. But do we even know enough how we might want to be able to represent such signals with a minimal loss?
Well, my understanding was from Gwen that just getting the correlation coefficient at each sample offset from time zero was what he was looking for. So
okay.
This is so you're talking about the whisper spots, is this?
No, we're talking about the tone pulses that have come off of WWV.
The tone.
Well,
okay, the tone.
Well, I mean, the other thing too is, I mean, if you're preserving stuff, a good example would be like taking a glance at the presumably open source algorithms that the QESDR uses for ARDF and hyperbolic signal location. Because if you could preserve a modicum of that, at least snapshots, then you could use a shortwave broadcast station in a known location without any special modulation techniques. I mean, not to mention the wave profilers and things like that. We don't want to, we want to get something working soon. I'm just wondering if there's something we could build into it from the beginning that would allow us to do these things later on without doing it all again.
One thing I was going to say is, would it be beneficial to save any of the IQ data to like Bill Engelke's server? And then you have the digital RF IQ files that you can post process.
You're talking about 8 gigabytes per day per channel.
Yeah, that's
okay. 82 gigabytes of recorded data per day per
so
site.
the answer may be no, but
there's a continuum here, right? At one extreme, you've got the 24 kilohertz 32-bit IQ samples. At the other, you've got a single number that says, hey, it looks like the peak correlation was at 5.5 milliseconds. And then there are stops along the way where you say, well, Why don't we give you 720 lags of the correlation coefficient? And then, like Clint said, maybe there's something that's, 10 times more data, but 10 times more useful. I don't know what that is, but it's possible it's out there.
Yeah,
Well,
I mean,
Yeah.
Clint, you're talking about generalizing this beyond receiving WWV, right?
well, yeah, I mean, we have to because,
I agree. Thank you.
yeah, I mean, the advantage of being able to use just a random, like Voice of Romania's 500 kilowatt broadcast is that gives the Europeans a whole lot of data they can use locally. I mean,
Yeah.
I don't know how to pull this off. And as far as the data collection, I was kind of thinking the back of my mind the StatNogs model, where researchers or people with proper credentials could request buttloads of data,
Mhm.
you know, and then the servers have enough memory that like it'll when you request this data, it'll be here for a couple of days, and you better get it,
Yeah.
soon.
And
Or it
there
goes away.
there is a feature in the pipeline for doing that sort of thing.
Okay.
So like there's I was talking about what Bill and Christina have been doing. There's a lot on that board to implement. So and that
Oh
is
yeah.
one of the things. But with this again, maybe you don't need, maybe you can store some subset of the 24 kilohertz, but not the whole 24 kilohertz and still have it be useful.
Well, I mean, on most of the sites, we can record a couple of days of full spectrum recordings, and that's what those are cached at sites.
When you say
At
full
most.
spectrum, you're talking about like a 20 kill sample IQ.
Yeah, 27. Yeah, so
When you said full spectrum, I was thinking of what I did for the two
no,
eclipses. Was
no,
record all of 30 meg.
no, I'm not doing that. No, I'm not doing
Okay.
that.
When
That's
the
not.
data still exists, by the way, it just nobody's looked at it
Doesn't
hardly
that's
yet.
I know
accurate.
I have hard drives in my garage, 10 terabytes, fill up
Yeah,
in a day.
Yeah.
yeah. So
Anyway.
I know when I say it's full IQ spectrum, and
Right. Okay.
and of course, moving to 24 kilosamples will decrease the storage time. But I was putting the data as an option. I was attach an external hard disk and put the data there, and you can record months. But we've encountered this problem at DP0, which was the external drive went bad and started to uh, impair the operation of Linux because it was just generating all kinds of disk I/O hangs, and then it started spewing messages into syslog, and eventually DP0 went down, and we thought maybe permanently. Fortunately, they seem to have brought it up. Um, but it adds one more fragile element to the chain to do these recordings externally. But the three, what was it? I think I only spent $225 last year, and I got a Seagate 20 terabyte drive for that, which records at 400 megabytes per second, well beyond our needs. Um, so one could, we could have a site, as the server post a request for a client to say upload this, deliver this data to this site.
And
And
not
so
so cheap this
researchers want
year.
it, right?
Dave, did you have a comment?
No, I just said drives are not so cheap this year.
Yes, I suppose they're not. They were a real bargain. But anyway, hopefully they will come back down to from the stratosphere. But in any case, we can store as much, many days as you have storage space for, and you can reclaim them.
Well, also
Uh,
remember Clint's pointing out that this data does not need to have an infinite lifespan. You can have it, have a time limit, and you roll over your
that's how it works.
storage. And,
That's
people have to know that, to request it if they want it, they have to request it before you before you start deleting it. But so the amount of data does not expand infinitely
I set
if
a
that's how you
threshold.
design it.
Yeah. If you enable Whisper Demon to do grape recordings, it will fill up wherever the disk's partition that wherever it's caching it will fill it up by default to 75% full. And then when it reaches that point, it will delete the oldest day's data in order to free up space for today's data. And it continues that way. It is, if you have an external drive, I allow you to set the high watermark, and on the sites with external hard disks like KPH2 has an external hard disk, I set that threshold at 95%. I mean, as well, use all of the disk. Um, but but so the data is there. But Gwen is eager to start looking at the correlation coefficients. So I don't want to do something that precludes. I don't want the perfect to impede us getting something. And it sounds like it at 24 kilosamples. Um, what is it? 720 samples would for a correlation coefficient array. Would be appropriate. But we need you, Scott. I guess you're the person whose software would generate that at the end of when you do your correlation coefficients. Right now, I think you come up with one number, right? It's what's the offset is.
Yes.
Okay, so but that number is the peak of an array that
Yes.
you. So
Well, now some of the systems actually have 5. They have 2 samples either side of the peak so that you can work backwards and
okay.
check the interpolation. That was just for
Okay.
debugging.
Okay, well, in any case, you're picking a subset of what is an array or could be an
Absolutely.
array.
That's exactly right.
So my feature request here is
Yes.
have an option to somehow output that array, that the whole array, and with the however long the window you're searching, output the array, and we'll and to maybe to specify whether it's the floating point value that you're using internally, or and maybe you do it as a floating point value, whatever. Don't you do the conversion, but then we can decide in Whisper Daemon. We'll take a look at that array and decide how it wants to append it to the extended spot data that it's putting up to the Whisper Daemon server. Does that make sense?
Yes, but I have another question on scaling that may be too in the weeds. And that's, is there any value to the absolute unscaled value of that correlation peak that may tell you something that is interesting? We may not want to blindly scale it. Okay, the max is, 1 and everything is less than 1. If the
Well,
max is 0.1 versus the max is, 1 to the e negative 6,
yes.
that may mean something.
Yeah, I I don't know what you would scale against.
Exactly.
That's the question. So I don't
So
know what the
floating point
base.
may make more sense in that case.
Yes, I think you should output what you get right now in your floating point values you get. Just have an option, command line option to output that whatever those floating point that array of floating point values is, output them to a file or someplace, someplace where Whisper Daemon could find it, and in the same directory where you're putting the um, you're putting the WAV file. So basically, it'd be an array. Wherever you're outputting an array, and of course you're putting an array for each of the recorded uh, signals. So you right now are outputting 10 files, IQ files. Um, so you'd have 10 associated. Each of those WAV files would have an associated correlation coefficient file. That make right, because that's how you're right now you're generating a correlation coefficient for each of the 10 bands.
Yes.
Okay, well,
9.
9. Okay. Well,
Yeah.
that's right. That's
Skipping WWVB.
Yeah, you have B. You don't have to do it on B. Okay. Anyway, so does that make it simple for you to implement, and it preserves all the data that you have, and that we can.
Yeah, that's a fine start. I fully expect it'll change once we get it to go in and play with it, but that's fine.
Okay, well, it's a minimum amount of work for you, and maximal flexibility with what we do with the data that you give us. So we'll learn something. I'm sure we'll go through some gyrations. So
Yes.
thank you. It's great though. This is great, and So anyway, I suspect that it would make sense then for you to come up with that. And share it with me before we try to give it to Phil to incorporate into the K9Q project. And you can do your experimentations on KPH1. I think you're set up there, aren't you?
Yes.
Okay. I did go and set up KPH2 to listen to the streams coming from KPH1 because the KPH2 888 has disappeared. But there's other problems out of KPH, and there's talk about going out there maybe next Saturday for other reasons. Uh, they're talking about bringing online these other antennas. They have a TCI 540, which is a low angle antenna, and 2 or 3 rhombics, all in some different states of repair or disrepair. And but this was not something I initiated, but since they're talking about doing it, um, I think we might get some interesting data from them, and I'll have occasion to go out there. In fact, you're not around, Paul, so you wouldn't. You're up north. Oh, speaking of another site that's down, where are you going to go work on? Uh, uh,
Steve
Steve.
Roberts and
Yeah,
for RVE. Yeah,
yeah.
I'm gonna. Yeah, I'll go over there take a look at it. Um, Rob, Steve is gonna be moving off island. The receiver could stay at his current location, although it'd be more difficult to access. I'm wondering, do we want to move that uh, entire receiver site over to my place here? You know, it's close to assuming I keep my whisper sond still running, but it's close to that. But especially if we're going to use one of those vertical probe antennas, it'd be easy enough for me to set up. It'd be several hundred yards away from my transmitter. Might be easier to maintain that.
I know it'd be easier. Um, let's see. Well, I'm thinking of a comparable site. DP0 is the closest comparable site. Yeah, I mean, they've got a transmitter. The whisper sond is at the main base station, and the 888's 1.5 kilometers away. And I haven't studied it closely, but it does seem like when the whisper sound is transmitting, the receiver, it doesn't overload, it just gets deafened. It doesn't really hear so much. So
That's interest. Yeah, and this will be a lot closer than a
yeah,
kilometer.
yeah.
I'm interested though, if it's not overloading, how is it being deafened?
It turns down the AGC turns down the
Okay,
gain.
AGC then. Okay.
Okay, K9Q turns down the gain
Okay. Okay.
for the duration of the transmission. So you know, it's just the noise figure gets bad.
Well, if I can figure out what's going wrong with Steve's site, I'll just it'd
There
be good
is
to keep that running. It's in a
a
great location.
yeah, I mean, my experience is, once if they're set up properly now, that they they can run for years without
Yeah.
intervention. So it's a
Yeah,
it,
I have no, I really don't know what's going on there. And Steve says he has not yet. He was going to pack up the receiver and send it to you, but he hasn't done that. So I think there hasn't been anything done. Anyway, I'm going to take
that
a look, see what I can figure out.
there was someone was helping him. Was it Andrew or something was helping?
Yeah, he's on another island. I don't know.
There's another guy who's running Whisper Demon that's part of the club who is a contributor. Um, I wonder if he might be a candidate for that setup. I think let me go look at the map and see if I can find out. But he is a club member who is interested in uh, whisper and propagation, and is remote from you,
Okay.
relatively remote. So I wonder if he might be a candidate. I mean, uh, I think the
The
most.
yeah, get me his name. I can try to make contact, and unless you're already doing that.
Yeah, no, I don't.
Another question is my transmit site here of any particular value? The Friday Harbor transmit site. Would it be better just for this to be a receive site at my house here?
Wow, that's a good.
Well, is there another place on your island, a neighbor that you could pull off your transmitter that's far enough away? Because the receive sites are harder to come by than transmit sites because
Yeah.
you don't have to worry about local QRM on the transmit side.
Yeah, I don't.
Well, you can find any number of places that are noisy RF wise and pop a transmitter down, presumably, in theory.
No, I understand. I don't know that I have the contacts here that I would need in order to find a site
Uh,
for the transmitter. But Rob, if you can figure out who that person is, I can help them set that up if they want to host the receive site.
Yeah, but Clint makes a good point. Transmit sites require almost no work to maintain,
Yeah.
and so if
Or
you
if you can find someone that wants to host a whisper sound, and I can move the receiver onto my location here. I've got a good location. It just happens to be, right next door to my transmitter.
yeah, let's see, W6EOD. Who's this?
Hey, Paul, what you need to make is a doohickey that takes a sample of the transmitted signal and phase combines it and cancels it out before it feeds into the RX888.
Yeah, no, just
That's another thing. That's yet another thing you can do.
it'd be like noise canceling headphones, but for a receiver.
Right?
How
Yeah.
hard could that be?
It'd be like the MFJ or DX engineering noise thingies, except they twiddle the knobs automatically.
Yeah, on 8 bands simultaneously. Yeah.
Well, there's a point to that. Yeah, I'm not saying it'd be cheap, but then again, it's never stopped me so far, right?
Well, in my spare time, I'll work
There
on
you go.
that.
Yeah.
But Rob, if there's somebody that I can get in touch with, let me know. And maybe I can, maybe Steve Roberts' location is, perfectly recoverable here. Well, I'll see what I can find out.
Yeah, we miss it. I think that I think my sense is the receive location is more important than the transmit. So that's my um,
Well, I could try to, I could set up a receiver here and, maybe, and also, if we wanted to have a transmitter here too, just instead of every single frame, have it transmit one frame out of 10 or something, um, or not at all.
yeah.
So
Okay.
anyway, I'm flexible, somewhat
Okay.
flexible on this.
Okay. Well, my internet search does not pick up that receive site in your region. So I don't know that. Let's see. You are located CN88, huh? So I should do.
Uh, Yes,
Yeah, I see.
correct.
Yeah. So, okay. Well, let's see. Demo queries. Okay. The let me look for that's. I'll look for things and see if I can't come up with it. But I don't immediately in the last hour. That person I who I thought was also reporting for some reason it was like KX7 something, and the um, the I don't see them, so I don't see. Do I have my queries? No, I have no edit. Okay, I don't have any queries here. So I'll look and see if I can come up with the call sign, but it maybe he may no longer be doing it. So use
Okay, I mean, I'll ask at the Ham Club here too. We've got a email, group chat thing. Maybe I can find someone who would
yeah,
like to host a
yeah. I th
transmitter.
Yeah, it strikes me that one of our greatest resources is the network of individuals geographically distributed who are interested in supporting and actively maintaining these sites, because that's, I think, what impeded Professor Heisel's research was just not having people who were interested in maintaining these sites.
Yeah,
So then
well,
they,
I mean, Nathaniel, you've got a project going, that and equipment available. So Rob, we should definitely be talking with Nathaniel about finding new locations.
yeah.
Well, that's where Emma's trying to get those whisper systems out the door. So
Yes, get them going.
we're working on
Well,
it.
by the way, I don't know if you noticed, I did upgrade Bob's W1XP's site. I gave him new software and I configured him to contribute. So his recordings, and he's got a superb receive site.
That's great.
It's a it's he's behind Tom Paratori and Conrad, but
Hmm.
not by much. It depends on the day. Uh, but he's number 5 today worldwide. That's it. I think conditions are pretty terrible, right? There's a solar storm happening.
Yeah, the last 2 days there was something.
So if you look at top sputters, the which the you can see BFK as always is at the top. This is Tom. Um, and then, we got this guy in Southern California, um, David Gonsalves. Um, and then this is Conrad, and here's Bob. And
Wow.
here's you, Clint. And there's me at KPH2. And here's New Jersey.
Hmm.
And now we're down to K1RA. I don't know this guy. I don't know what he's running. And here's you again, Clint, and there's KFS. And most of these, this is Wayne, who's made major upgrades. The browser, the web interface has been significantly enhanced. Phil, your and Wayne's work is a noticeable improvement. Really it's really a pleasure to look at this spectral display.
Well,
And
Wayne's been doing most of the work lately.
well, you've been supporting him well. So he's
Yeah, I've got 44 net addresses on all the KFS machines now. If anybody wants to try out KNIQ Web, it's open now.
yeah.
Let's go to kfs-omni-swsw.ka9q.net:8081. And comments, compliments, brickbats, whatever, of course, welcome.
Yeah. Well, I verified the interfaces work. I I have I don't really have any machines out there that I give you, so you can use one machine as the interface point.
Yeah, well, right now I've got a separate tunnel, standalone tunnel going to each one, but I've run into ARDC's limit of one tunnel count. I mean, I'd rather keep it this way because then I don't depend on a common point of failure.
Yeah.
Can you put one of the links in the link in the chat?
Oh, sure.
Bill?
Sure,
Thanks.
sure. Let me do that. I think I'm doing that. HTTP. It's not HTTPS, so you do have to type this part. Yeah, I put them under kniq.net because I mean that was a handy zone that I have. Rob didn't want me putting them under anything that's owned by KFS. So
Yeah.
right now they're open with no access control. I'm a little leery about the amount of load that the audio streams are going to generate because it's still on compressed PCM. I think it's a high priority to get them to transfer Opus. With Opus, I mean, the bit rate is so low that if we put a timer on the spectral display, a timeout, then people could basically stay in indefinitely without bothering anything.
Well, I guarantee you, if they can, they will, and you won't like it.
Oh, I'm sure if people just want to sit on and actually use it, that's fine. I mean,
No, you don't understand. We've had problem in northern Utah. They'll camp, like there's a guy that opened up a crap ton of streams and then is monetizing them on his YouTube page. And we're wondering where the hell this is coming from.
I see.
And they will do that. They will do that and do that and do that.
Well, hey, you can beat them at their own game.
Well,
People actually want that. You can put up a YouTube page yourself.
well, right, but it doesn't. I mean, it vacuums up bandwidth, and where we are,
Yeah, but I mean, how much?
we
I
have
mean,
limited bandwidth.
how much does one audio stream cost you?
Well, it gets out of hand.
Well,
it gets out. I mean, if you look at what the guy that does John Siemens has had to do to prevent this problem.
Well, he's got a problem of a really underpowered box that can only handle a couple users at a time.
Well, but it'll handle more. It'll handle multiple streams per receiver, and so. But anyway, it is a problem that you don't want to ignore.
I'm aware. Actually, the bigger problem I'm concerned about is simple packet flooding. A service attack, wasting the bandwidth on the tail link of the tunnel. That's why I haven't set it up in either of the polar sites yet. I talked to ARDC guys about putting in some kind of optional user-controlled filter on the forward link going to the user to throw away packets that we get thrown away anyway, just to keep them off that link because they're using Starlink, and I don't know what it costs them.
Right. Yeah. I mean, if people will can take advantage of it, they sure will. Yeah. I know bandwidth is cheaper, but still. Yeah.
Yeah. I mean, I usually let Opus, pick a bit rate that it thinks is good for whatever the characteristics are I'm giving it. And for 12 kilohertz sample rate mono HF quality, sideband or CW, it usually runs around 12 to 15 kilobits per second, which is basically nothing over most internet links. And of course, KNIQ radio can handle hundreds of those channels, so that's why I'm not terribly worried. I mean, if it becomes a problem, I'll fix it.
Hey, guys, can I jump in here a minute? I wanted to ask about the capabilities of what's possible now with KNIQ radio and the time stamping. So from what I understand, is the time stamping that is it's a BPSK carrier that's modulated by the pulse per second. So it's keyed by the pulse per second. Is that what I'm understanding?
Yeah, that's the time sync signal that's feeding into the RX 888. The phase does 180-degree shift once a second.
I see. Now, so now that uh, we know where the second is in the RF stream. What's done with it after that?
Well, finding it's, that's a trick, and that's what, Scott's been doing. But yeah, what happens after that? That's Scott, are you still here? Can you describe that?
Yeah, we've got a modified version of PCM record, and you pass it a command line to tell it either the SSRC or the carrier frequency, and it records that channel, and it just looks for that 180-degree phase shift. Does some, heuristics to say, okay, is it within 99% of where it should be? And you've got 10 good pulses in a row or whatever. And once it's locked in and knows that it's a solid pulse per second, it will start recording at the next top of the minute exactly on that sample.
And is there any time information recorded anywhere? Like, could I, is it possible to pull out timestamps?
The wave files are named for the second zero of the minute. They're minute long recordings. They start at second zero. The start time is keyed off of that BPS transition. So the first sample of the wave file is associated with the BPS, is correlated with the BPS transition on the carrier, the signal coming, the time sync signal that's injected. This works because all of the demodulated signals, all come from the same sample stream. So that knowing where the time sync signal transition occurred, you now know exactly at the same time which sample was associated for all the other output streams.
I see.
Does that make sense?
So I can't take this wave file and just take it out of its regular place and glean some sort of actual like.
It sounds like you want to try to do something. What is it you're hoping to be able to do?
Well, so with the VLFR tool software, the timestamp is embedded within the sample. So I could take any sort of any data file and run it through the signal processing chain, and I could have a timestamp. But I'm guessing, but from the sound of it, it's done a little bit differently here.
Maybe the best way to think of it, Jonathan, is that all that my current code does is ensure that it starts recording at the top of the second.
I see.
If you know the timestamp embedded within the file name and what sample you are on, you can assure that whatever sample you pick within that minute file is referenced to UTC or GPS time.
Right. Okay.
Yeah. So you just pick a file at random. It begins at second zero of X minute. You're 20,000 samples into it at 20K samples. That's exactly 1 second later. As much as is possible to know at that temporal resolution. So for example, if you wanted to do your own Blitzer tongue thing from a number of sites, if RX888s could go down lower, you could do your own Blitzer tongue lightning detection by collecting all those files.
Yeah, something else, it's not the same as the VLF tools, but the RTP data stream that Phil emits does have RTP timestamps in it. And once you know where your pulse per second is, you can correlate those.
Right. Yeah. Which is,
Yeah,
which
it's
that's
If you wanted to
technically,
look at the stream instead of files.
yeah. Yeah. So what you're saying is that's currently done in VT time right now. But so those RTP timestamps, those are set using the system time, right? They're not. They're not.
No, this is more of a Phil
Calibrated.
question, but it's a sample
All
count.
right, I can speak to this. RTP timestamps are relative. I think they're set at 0 at the beginning of a session, although you can't actually depend on that in this.
I see.
What I do. However, I send in the status message, it comes out every 500 milliseconds. I send out a snapshot of the current timestamp along with the current NTP time, which does, the current system time, which does come from NTP. That way you can relate it to clock time if you want. It also sends the sample count since startup from the front end that has been passed through along as a tag along with the buffer. So, it matches the timing of the front end of the sample count at the front end when the buffer was originally read from the A to D converter. And that actually may be a better reference for you because that's typically clocked from GPS and therefore accurate. The NTP one is going to vary. Does that make sense?
Yeah. So they so what when so because what I was trying to understand is like
Wait a minute, sorry, I hit something here. Say again, please.
well so what I was trying to understand was
You're still sharing your screen, Rob.
Yeah, you're
Oh,
sharing the
sorry,
screen.
sorry. Oh, I didn't realize I was doing
Now,
that.
just before you log into your bank account or something.
I, I'm trying to do a query to look in and I can't figure out the query syntax to find out the region in how to match on a grid square. So let's see. And you know what happens is Zoom hides this. Where is it hides away.
I stopped your sharing for you.
Yeah, I can't find it. I can't find where to stop it. Thank you. Oh yeah.
I'm gonna head out for the night. Thanks for a good discussion, everybody.
Okay.
Thank you.
All right. So what was the question then, Jonathan?
yeah so I was so with what you do with the RTP timestamps, those are set based on the NTP time of the system.
That's right. I give you as much information as I have available in order to be able to figure out what the sample numbers mean.
I see. Okay. And then so with Scott's software, with Scott's software, there's no refining of that timestamp based on the on-off key of the BPSK signal. That's done technically after demodulation, right? And then after it's converted to wave. From what I understand.
I mean, the time signal will just be on a separate independent channel. It's a generic channel as far as CAN-XE array is concerned. And you'll have to post-process, correlate the channels to each other to figure out what the timestamps mean, GPS time. And if you don't use, I would not use the system clock time. I do include it, but because it's controlled by NTP, and in fact, the frequency is going to vary. I mean,
Yep.
typically
Yep.
it's a PLL, right? It's
Yep.
varying the frequency to try to drive the phase error to zero, but it's going to be plus or minus at least some number of milliseconds. And your better bet, I think, is to try to figure out a reference time for the A to D clock when the radio D starts, because that clock will be exact if it's clocked by GPS.
I
Now,
see.
I don't
Okay.
know. I don't know a time yet, but once you figure that out from a timestamp, you should be able to then say, okay, by looking at the time channel, you should be able to figure out what the front end sample was at a given clock time to the
Right.
resolution allowed by the bandwidth of that clock channel. You could use a very wide clock channel, depending on where you park it and how strong it is.
Understood.
I mean,
Okay.
if you made it a megahertz wide, you could get well within a microsecond.
Um, okay. Okay. So
like
then,
Phil just said, the most of the triple eights are running GPSDOs. So you've got a
Right.
consistent rate that's very accurate. And the pulse per second that Paul's come up with, that gives you your absolute time reference. So you've got rate, you know where the second is, and you can go from there.
Yeah.
okay. And then so in terms of the data produced, so you have your um, um, time beacon carriers and you have your whisper bands. So I'm guessing that for those two observations, you run those through a demodulator, and then that gets run through PCM record. Is that how I understand it?
Sorry, wrong bill.
Sorry, it's writing that by me again. I got three things going on here.
So if in the you're interested now in demodulating, right? So
Right.
so there's two observations now that HamSCI is interested in. There's the time beacon carriers, which is the grape type data, and then there's the Whisper FST4W FST8.
Okay, regardless of that, okay, what you want to know is you want to time whatever's coming in on any of those channels. So the way you get that calibration is that you look at the metadata that I'm sending on the channel that is carrying the 1 PPS that's injected into the front end. Okay. You get your time of day to 1 second precision, either by decoding that time code or by getting it out of band, or one way or another. Okay. And then you use the transition in the data to determine the A to D sample count number for which that time was valid. And now you've created a calibration point you can now use for all your other channels.
I see.
They use a common A to D sample count, right? The A to D, when it starts up at the beginning, starts with sample number 0 and keeps going. Okay. All right. So by looking at the on any particular channel, if you look at the last status message, you will see a snapshot of the front end sample count and a snapshot of the current timestamp. And then from what you see on the sample stream will be some RTP timestamps that's after that. So you'll know how many samples you are after that epoch of the last sample of the last snapshotted timestamp. And then you can reference that to a front end sample count. And then from there, you can reference to absolute time. Does that make sense? I mean, there's a pathway here. You can go backwards too and get all this calibrated. So now you'll know what A to D sample count at the front end corresponds to a given epoch of atomic time, of actual time.
I see.
And do that all the other channels, because you have the same information for the other channels, and then you can do the same thing. You'll just have to be careful with sample counts, because the A to D clock is increasing at the front end rate 130, 129.6 or whatever, and the output timestamp will be increasing at 12 kilohertz or whatever your output sample rate is. So that'll be a rational fraction. But once you do that, you should be able to get everything down to a pretty good precision. And it should stay there, assuming that you don't lose any A to D samples. It will stay there. You don't care what the NTP daemon is doing. That's just keeping the timestamps in your files approximately right.
Right.
This is why I always resisted trying to timestamp files and make them exactly 30 seconds long on and 30 and all that, because it's an exercise in frustration when you're dealing with a real-time clock that is not guaranteed to be that accurate.
That's true.
Yeah, when I decode FT8 or FT4, I just write files that are 15 seconds long or 7.5 seconds long or whatever, and I try to bring them close to, a round second, and I will trim if I have to, if it slips for some reason. And that has worked actually very well. I've had that running now for several months at all the sites, and it just decodes, and it just decodes FT8 and FT4 just fine.
And how and so what do you do to actually do the decoding? So you run it
For FT8 and FT4?
Well, just the whole chain from the receiver slice to the decoder.
Yeah, okay. Well, I have a system D job that invokes it's called FT8 decode, FT8 record or FT8 decode, and then FT4 and FT4 record and decode. And the recorder invokes PCM record with the right options to write down only 15 seconds or 7.5 seconds at a given start time. And then it writes it into a spool file with a file name that encodes all this information. And then a separate daemon runs through it and actually codes them all. And most of the time, one daemon is enough to decode all the files recorded from all the bands and plenty of time for the next cycle. So you actually don't need to have one decoder for every band. I mean, one for the whole system is usually enough.
And it so it goes through an SSP decoder or SSP demodulator.
I mean, FT8.
Right. Okay.
I mean, I could, if you really want to see the detail thing, log into one of the sites and show you around what's going on here.
Yeah, if you can.
If that would help, sure. Come on, KFS Omni. It's only a little sluggish to give me a login prompt for some reason. All right, let's see. Well, I'm doing now share screen. Okay. This should be, is that it? Yeah, this should be it. All right, you see a show window?
Mm-hmm. Yep.
It's on KFS Omni. Okay. All right. If I are you familiar with System CTL and System D?
Mm-hmm.
Okay. FT8. Well, I'll just pick FT8. FT8 record. There is one FT8 record task for all channels. So it runs one instance of PCM record, which understands how to handle multiple streams.
Right.
So it records into the directory varlib K9Q radio FT8. And I give it the -8 option, which tells it, this is a special case for the FT8 decoder, decode on 15-second chunks and close the file and open another 15-second chunk. And then FT8 Omni is the multicast group in which is receiving all the output streams from all the FT8 channels on that radio, okay? So if I then go into varlib K9Q radio FT8, and I look in there, you'll see these are okay, there's some old stuff in here that's not being properly cleaned out, but if I do this, watch minus N1 minus LS minus LT, you'll see the files are growing, see?
Yeah.
And then after 15 seconds, watch what happens. 42, 43, 44, 45. Okay, you see what happened?
Mm-hmm.
It was so quick that you hardly even saw while it was decoding, right? I mean, they all basically just disappeared because the decoder program went through that quickly and deleted them all after decoding. Okay. And it's supposed to delete these old files that are left behind, but they're not really causing harm. But the reason they're different sizes, by the way, is because I'm recording different bandwidths. I'm recording quite a bit more than 3 kilohertz in each band because some of the FTA segments have expanded so much, especially with the expeditions, that I just record, a good sized chunk of each band. And they're different. That's why the file size is the same. Otherwise, they'd be in lockstep. So I do the same thing for FT4, which is not as popular. So I just record fixed size chunks in each one. See how they're growing?
Yep.
Okay, and then they reset after 7.5 seconds. Okay, so there's another job running. Oops, type FT8 decode. Okay, so there's an FT8 decode job, and that is a modified version of a decoder that I found on GitHub that I
I got a bail,
modified.
guys.
Okay, can I? I
Good
heavily
night,
modified that to do the spooling subsystem. I got to rip the spooling system out, make it separate so I can send back changes to the decoder that don't have all the stuff they probably don't want. But that's the thing that is running through the spool files and decoding everything. You can have more than one. I only need one, but I wrote it so that you could have any number of these running if you really need the extra horsepower, and they will coordinate with each other, lock files, and then you only get one decode of each one. So the output of this decoder is here, ft8.log. Okay, so every 15 seconds, you see a whole batch of decodes come in. It's quite a few. I mean, it's a good antenna. So, and the bands are a little bit better than they were a couple days ago. The timestamp is the time at the beginning of the transmission. So like right now, it's 15 seconds after, so you're getting the one that was sent on the minute.
Right.
Okay. This is the SNR. I'm not sure how it's encoded. There's been some question about that. This is the timing offset from the beginning of the period. This is the exact frequency. And then, of course, this is the message. Now, I do not include the hash codes. This is something I need to do. I think all of these modes, including Whisper, use hash call signs because bits are so limited. And you need to build a hash table and then infer, from what you've been seeing lately, what call signs were likely the ones that were being hashed. And I haven't done that yet. It's really a problem only when you have call signs that are unusually long, like with a slash or something, because then they often have to use that feature. You'll usually find it in the destination field. The source field is usually sent unhashed.
Right. Yeah.
Okay. So this is and there's another daemon that is running on this status PSK report. Okay, there's 3 of these running. One for FT8, one for FT4, and well, maybe there isn't. Okay, I guess Rob's doing his own reporting, I guess. But these are scripts written by Phil Gladstone that report everything to his PSK reporter website. And all it does is just, as you can see from the command, all it does is tail that log file I just showed you and run it through a Python script that sends it to his website and then puts it on his map.
I see.
The Whisper should be there should be a Whisper upload daemon there as well.
Going into this file?
There's a Varlog Whisper, yeah.
Oh, it is. Oh, okay. Should this be going to PSK reporter? Does he have a
There should be a third PSK reporter at whisper.service.
Okay.
I think if you look to see if you can see it, you should status on it. I'm pretty
No,
sure.
it doesn't. I know the only ones running were FT8 and FT4.
Okay. Well, maybe because
it's a different
maybe
format.
it understands the format.
It does understand. Okay.
Yes, yeah, but I think because you're in charge of the WISP the K9Q world, I think you're also in charge of the FT8 world there. And
Oh, I
so,
can easily add the PSK reporter job if
yeah,
you want.
just, yeah, if you want it, it's
Yeah,
yeah, okay. The amount of, the data is being updated there.
yeah, that looks current. Yeah, that's the current time.
Yeah.
That
So
looks current.
at sites where Whisper Daemon installs and configures and runs
Yeah.
K9Q, then I also run the FT48 and the
Yeah, I
PSK
don't know
upload.
the meanings of all these columns. Obviously, is date, time. What's the third column?
The third column is a metric column, I think. It's we kind of repurposed it for FT4. It didn't the JT9 did not put it so that it's it basically is milliseconds of spreading, I think,
Oh, a
for
time. Okay, metric time spread. Okay.
yeah, so yeah, if you look at the last column, it identifies the type of it, whether it's a type 2, which is regular
Ah, yeah,
whisper,
yeah.
type
That's it.
3 means it's
Right,
an FT 4W package.
right. So fourth column is SNR. Fifth column is time delay, I think, time
Yeah, I
offset.
think yeah,
Frequency, call sign, grid square. I don't know what the next
yeah,
column.
and you can see that SP6 is a type 2 packet, a whisper type 2
Oh, it's
packet
a type
because
two. Oh, that's the
yeah,
packet type. I see.
yeah, see, and the above the on and angle brackets is a type 3, where the hash table Whisper can look up,
Yeah,
it maintains the hash table in a
right.
file, but the JT9 does not.
Yeah.
So
Yeah, hashing could be done in a separate. I mean, all you need to know the algorithm, and you
I
could do that. You could
well,
run a separate program on the log and create the hash codes, and then you go back and actually get ones that you didn't know at the time they were received.
well, actually, Steve Franke added an option to JT9 where it will, instead of doing angle bracket dot dot dot, it will on JT9 decodes, it will do
Yeah,
angle bracket hash right
right.
angle
But
bracket.
my point is, in order for that to work, it has to have already seen that call sign unhashed earlier. Otherwise, it
But
won't
yeah,
know
but
about
that makes it, Steve. That was Steve's when I asked Steve, why can't Whisper Demon? Why can't I find the call sign of why do you maintain the hash file in memory in a place that is very difficult for to the mechanism to
it. Yeah,
feed
it's
to the
state.
G.
It ought to be preserved between runs. I mean, does it go away when you restart it?
It goes. It's yes.
Yeah.
The way they run it. Okay,
All right, you
JT9.
answered the question. Yeah,
Yeah.
they keep it in memory. That's
Yeah, they have a memory
yeah.
interface as they input into JT9. So they invoke it
My
once and
point is
it
though, is you could write a standalone program that would look at the logs that all the recent call signs have been logged, hash those, and use those as
well
candidates.
that he punted. They said that's for me to do, and I've never had
Yeah.
time to do it. To me, I mean, there's so few of the four Ws that it's a very low priority for me to
Now, I
to
see a bunch of them right here on the screen. I see one, two, three of them.
Yeah, but those are
Um,
whisper. Those are whisper.
yeah,
Those are whisper two. Those
yeah.
aren't FT4s. You don't. There isn't. I don't think it's.
Oh, okay. Oh,
It's the FT4 type 3 packets that have the hash table in them. If you grep whisper.log, look for the if you look for the last field being a 3, you may
I
find
see a
some.
bunch of them here on the screen.
Yeah, you can see a bunch of them. Well, they're all identified. They're type 2, so the call sign is full.
The ones that are in brackets are all type twos.
Yeah, but
Um,
there is
yeah,
probably
well, they're
farther.
type, they're this because they have the subsquare, and that's actually kind of important. I mean, a grid square is pretty big.
Yeah,
So, like if you use DM12, which is my square, it'll say that I'm in Mexico because the center of the square is south of the border.
yeah,
So, people
yeah,
sometimes have to be careful about adding their
yeah,
subsquares that they,
yeah,
don't want to
yeah,
mislead people where they
yeah.
are.
Yeah. Now, if you go and do a query of these spots once they're uploaded, you'll frequently find whispernet.org puts in the full six character grid square, even
Oh, it
though
probably already knows about it from earlier
it
reports.
it knows about it from if not from earlier
Yeah.
reports. Also, it looks. I think they look up in their user database, and when you register yourself on
Yeah.
whispernet.org, if you put in a 6 character data location,
Yeah.
They may go and
Understood.
use
Yeah.
that.
All right. This is what typically looks like on a site running. Well, I guess it's running Whisper Daemon as well as FT8 and FT4 decode. So this is typical.
Yeah, you're running. Let's see. This is Omni. You're running.
This is KFS Omni.
Yeah, this is so. I like the way you've been more explicit in the command names.
Oh, that's the thread names. Yeah,
yes,
I changed that when I was it's the type of decoder and then the SSID or SSRC.
Yeah.
So you can see that the big consumers are the usual suspects, FFT, and then the thing that handles the A to D converter directly, PROC RX 888 in this case.
Yeah, you'll
And
see.
PCM record is using a lot because there's one PCM record for all of the streams. It multiplexes to disk.
Yeah, you should
multiple ones.
Yeah, you should also realize that I have the CPUs running at 1.4 gigahertz rather than their full speed.
But there's still plenty of cycles here.
Yeah, that's right. Yeah, it keeps the CPU temperatures down quite a bit.
I have HFDL running on this one. Usually, HFDL is running.
Yeah.
So yeah, it's not taking up that much.
I don't know. I learn more from BTOP than I do from TOP, but in this.
Nice to get one of Nathaniel's students to start looking at this data to see if there's anything useful that can be mined out of it. This is all the HFDL packets. Each one of these is a base station or an airplane sending a message on HF. And
looks like JSON.
This is unreadable JSON, but in there are, frequencies and airplane IDs and latitudes and longitudes and all that kind of stuff. And it includes a lot of overhead information, signal reports from the airplanes saying which ground stations it can hear and how well. And that seems to me like it ought to be useful for some sort of propagation research.
I would think so. You're uploading it to some.
I'm uploading it to a site, an aggregator, similar to the ADSB aggregators. I think they're affiliated.
Mm-hmm.
So then does it get uploaded in this JSON format, or does it get parsed somehow?
Well, I mean, you select what format you want, and they wanted JSON, so I selected JSON. Plus, I'm writing it to a log file locally just so I can see it that it's working.
I see.
There's another format you can have it print, which is a little easier to read, but it's not what they want. So.
Well, I would think for radio transmissions, I would think you'd want them to be some kind of binary compressed format.
Well, I mean, the actual message is, I mean, this has after it's been decoded and interpreted. Yeah. I mean, the messages, the binary messages are highly compressed, because highly encoded because the messages are so small. They typically transmit only 300 bits per second, and each packet is only a few seconds long. So there isn't much room for data. It's differential phase shift keying. I think it's 8-phase differential phase shift keying at 1,800 symbols per second, something like that, with a lot of coding. It works surprisingly well. I mean, it can often decode when you didn't think it should decode. But it just seems to me that there ought to be some useful HF propagation data in here somewhere. If some grad student wants to start watching.
Do they identify where these things are?
Yeah. They give their latitude, longitude. They give the ICAO ID, which is a 24-bit number, unique number to every airplane, encodes the tail number.
Yeah.
And much of the traffic is overhead, these signal reports of who they've been able to hear and how well. Plus, you can often hear the ground stations directly, so at least propagation is good from that location.
So each one of these is a burst of multiple receives in that time window?
Each one of these is one. Well, I mean, all the outputs, all the receiver outputs are being put together into a common file, but each one of these updates is one message. And some of it can be pretty big, not because the message is big, but because that's how they expand. The ground stations send not only messages to the planes, they also send these overhead beacon messages called squitter messages that list all of the frequencies that they're using. Plus, they rotate around the other stations around the world and give their frequencies so that a receiver can acquire just by starting on one frequency and listening long enough and hopping around, it can acquire the strongest ground station. Of course, when you can listen to all the frequencies at the same time, it becomes a lot easier. So I don't even try to do that. I just record everything everywhere because it's so cheap and easy to do.
Yeah.
Yeah. And I mean, this is really good, like for what you're doing. But I don't know how this could be made to work with the VLF signal processing that I'm doing.
No, I wouldn't expect it would. I mean, it's more just as a general indication of what's going on with HF propagation. It won't give you Doppler.
No.
These transmitters are not GPS locked, plus they're moving. So there's a lot of Doppler shift on just because of airplane motion. But they do transmit from places that hams don't go, right? I mean, a lot of these are over the Arctic or over northern Canada or over the oceans and, places that hams don't go.
Yeah.
So it can give you an idea of, just a rough idea of what propagation is like. So, this combined with FT8 and FT4 and whisper spot maps, I think could tell hams a lot about, where bands are open and for what.
Yeah, this I don't believe this would be useful in VLF.
Oh, no, I didn't think it would be. It's just another piece, if people want to monitor space weather, it's another piece of data that might be useful.
Right.
Jonathan, you in your description, you say that your VLF tools somehow extract the time of the recording. Are you getting a continuous stream of audio from the receiver?
Correct. So how it works is that that the software VT card, it reads the samples from the sound card. And when it does that, it also acquires the a rough timestamp from the system time, for example, NTP. And it also uses NTP to do like a rough frequency calibration as well. And then it runs through VT time. So VT time looks for the pulse per second signal in the other channel. So when it finds the characteristic that it's looking for, it makes a determination, and then what it does is it does a more finer frequency calibration and timestamp calibration. So remember how I believe Phil was saying that that like you could extract the timing information that you need from the timing carrier, and then from there you could offset your timestamps and adjust them or calibrate them so they're aligned. And in this case, this is what VT time does. So what it outputs is a calibrated frequency and calibrated frequency and time-stamped stream. And the timestamps are attached to each sample. So there's metadata on each sample, which is the timestamp.
Speaking of metadata, these are the external attributes that I'm attacking on each of these files that gets recorded. And I do pass some of the information into the decoder this way. You can see a list of what I've got. Normally, the starting time and the frequency and the mode are encoded into the file name, as you can see, because that's what the decoder expects, and that's what WSGTX uses also. But I wanted to add more information in case it was useful, and I just realized that one of the things I need to add to this is the timing reference back to the A to D sample number. I need to add that. Now that information is available, I can add that here. But you see, I do have a Unix start time, but that's just the NTP time. That's the time of day clock of the Unix as a count, from its epoch. So that will usually match the modification time or creation time of the file. But I need to add one. I'll probably add one that says, I don't know, sample reference or something like that, giving the A to D sample of the input that corresponded to the first sample in the file. Right. And if you know how long the system's been up, you can then turn that into an exact clock time.
Yeah. Hey, Jonathan, you're doing all this. Is this done as post-processing? So it's working with files that contain this or is this real streamed process?
No, this is not, it's not working with files, it's working with circular buffers.
Okay.
So you have to pass all your metadata to this memory.
Yeah.
Yeah, I mean, if you pass them in files, then you have to get a little more formal about where you're going to put all your metadata. And what I like about external attributes is I don't have to have a funny file encoding. The file itself contains just PCM data, and this is all external to the file. Not every file system supports this, but most of the important ones do.
What I find interesting about the VLF tools approach is that to deal with the non-constant sample rate of the sound card, it looks like he's actually resampling once he detects the pulse per second to make the output stream consistent.
Yes. Mm-hmm. Yeah.
How much does it vary? I mean, it's the clock, or crystal, whatever it is on the sound card that he's using.
Yes.
There's no way to fix that. Huh?
I have seen people apply, like a GPS reference 5351 to the input of the Behringer.
Yeah, you could do that like into a second channel or something, similar to what we're doing at RF.
No, this guy was replacing the crystal oscillator in the sound card.
Oh, I see. Yeah, that would be the ideal way if you can do it. I find that doing sample rate conversions sometimes seems like a simple solution, but especially when you're making very small sample rate changes, ratios close to 1, it can be a real bear.
Yeah, I don't know how VLF Tools does it. I've never looked at that code.
Yeah.
But he claims 50 nanoseconds in his page, so
yeah.
Good.
Yeah, so yeah, that was one thing that I forgot to mention was that VT time will actually resample. So it resamples everything to something fairly constant compared to the change over time of the sample rate of the sound card. So it'll actually, so how much the sample rate varies throughout the day kind of depends on the obviously temperature. You could kind of use it as a very, very rough thermometer when you actually plot it.
And what are the input and output sample? What's the sample rate conversion ratio? Is it close to 1 or is it something else?
Let's see.
Close to, like I said, close to 1 can be difficult. I don't know how the algorithms are.
Well, it shouldn't be 1, right?
Well, it won't be 1 unless it's already exact.
192K in, 192K out. And then it's very close to 1. Plus or minus 20 parts per million.
Yeah, I mean, if you're going to convert the sample rate, you might as well make it whatever it is you really want, as opposed to what the hardware can do. especially if the bandwidth you need is a lot less than what the hardware can support, because then you could add really tight filtering and use a sample rate that's very close to the Nyquist limit and not waste a whole lot of bits.
Um,
Oh, I know why I need all these FFTs. It's because I've been running Spectrum. I've been running KNXT Web with all the different Spectrum zooms. I was wondering why there were so many of these. This is how I do FFT wisdom for oddball sizes.
Yeah, I just zoomed through all the sizes and picked
Yeah,
out all of the coefficients and put them in a table and run the planner through all of the
yeah. That's what this does.
yeah.
FFT Gen just runs the planner, writes the output into that
Yeah, you do
wisdom
yeah.
file. I
Yeah,
don't use
well,
the system wisdom file. I mean, I'm making this an application specific one. It's just
I
as easy.
I save it the planner's output when it creates a wisdom file. I put it both into your directory and into the system directory at
Yeah,
the
I don't
same
think
time.
that hurts.
You say you check both places. You
I
print
do
that out.
check both places. Yeah,
Yeah, but they're the same after it's
yeah.
after I'm done with planning. But
I can't see the lower left-hand corner of my screen is covered up by an icon.
you can move that
There it is.
icon.
Oh, I
Grab
can
it.
move
You
it.
can move. Yeah, you can move it up
RF
to.
129 and 600. What would that be?
Yeah, I don't
That must be
recognize
one of
that
the
one.
bigger spectral.
Must be one of your
Yeah.
HFDLs. I don't,
No, it's
because
not. Well,
I don't
no, it's not
recognize
because
that.
F means forward.
Yeah,
If R means real, out means out of place, and F means forward. So it must be one of it's one of the wideband spectrum analyzer modes. Depending on what you ask for as a resolution bandwidth, it'll use a different size FFT because the bin sizes have to match what you ask
yeah.
for.
I haven't checked since you made those spectrum changes to make sure that I'm pre-calculating
Yeah,
everything.
I actually can do this.
But you'll tell will you tell me? Radio D will tell me if it's missing
Well, that's what this file is. That's what I just did.
yeah.
I mean, if you look at
Okay.
this file, okay, see the command
Yeah.
I'm running? It's a verilib K9Q radio. If you look at fft.log, it just appends all of these lists of sizes
I did.
that it did not already have wisdom for.
Okay. Oh,
It
I
puts
see.
it in there.
Okay.
And then the FFT, the command that I'm running, that command writes
Yeah.
its output into that wisdom file that you see right here, the
Yeah.
application wisdom
Yeah.
file.
Yeah.
Okay.
Yeah. Yeah. That's okay. Well, it do essentially the same thing.
And well, it also updates checkpoints after each one. If you run their wisdom file, it basically zeroes the output file, doesn't write anything to it until all of them are done, which was a real pain. You lose
Yeah.
hours of work. So this one will
Yes.
update after each one.
Yeah, I didn't use that, and I mean, I have. It's been fortunate. I've automated the whole thing, and the only bad aspect about doing it automatically from a table, pre-generated table, is that initial startup. If you start it up as a system daemon, which most people would, all of this information about as it's doing it, it's calculating. All that goes into the syslog, and most users don't know to look there, and they
Well,
wonder why is that.
I didn't think that was satisfactory either. That's why I came up with this new scheme that logs it here, and then I made a tool that makes it really easy for you to just
Yeah,
generate the wisdom from it. This is
yeah.
far easier than that.
Well, anyway, it's something I'm thinking about, and
Yeah.
so this is your program, FFT Gen?
Yes, as part of
Okay.
KNIQ Radio. I'm now
Okay.
running this on the other KFS machines, which I hadn't done either since I
Yeah.
installed KNIQ
Okay.
Web, which is still
Yeah.
new on these
Yeah.
machines.
Okay. Good. Well, that's good. So this is taking it out of the radio D log.
No, Radio D itself logs it here as
Yes.
verilib KNIQ Radio FFT.log.
Yeah.
And
Yes.
that's what's in it. Each one of
Okay.
these represents one transform size.
Yeah. Okay. I
Real or
understand.
complex, out of place or in place, forward or backward.
Okay.
Yeah.
Um, so this just output ones that are missing go into that
That's
FFT
right.
log.
Only the ones for which it does not find existing wisdom.
Good. Okay.
And
That's
it will still run. It'll run with an estimate, so it will run
yeah.
slower. So,
Yes.
if you do
Yes.
this, then restart. You have to restart for it to pick up the new wisdom,
Yeah. That's okay.
I
That's
think.
good. Okay. I'd I wasn't aware of your FFT.log.
Actually, I could change it. I could test to see if the file's been updated, the wisdom file, and then reload it if it is. Save everything and restart.
Yeah. Well, there you are. You're busy doing that's the 64 megasample forward. So that's and there'll be another the 32 4000 that will take forever. I and the time it takes to do these planning runs does not correlate with the power of the CPU.
Yeah.
I did one on for Tom Paratori over the weekend. He just upgraded to a i9 14900K, which is a pretty darn powerful. It's a 20 core, 32 core a machine, and it took it about 3 hours to do the planning.
Yeah. Well, for the bigger ones, yeah, it can definitely take a while.
And that's that's of course it's a uh, single core. It's you can't parallelize the
Yeah. So
so
we have this machine back.
yes, isn't that good?
Yeah, but it doesn't look like he unplugged the drive, I guess.
Well, there's no drive. The drive isn't there. I mean,
Well, it's plugged in.
it's plugged in, which
See,
I wish it
is
had.
that the one you sent down, the Seagate
Yes,
wireless?
yes.
So
It
that's that
is.
he didn't
Yeah,
unplug the bad drive, so it's still
he
there as a
didn't.
landmine we can trip
Yes,
over.
I know, but we marked out the FS tab entry.
Yeah, I'm just worried about utilities that may scan all the drives on the system,
Yeah,
whether or not they're being used. That's what I'm
yeah,
concerned about.
yes. Well, you caught that. I just don't know how to avoid. I think that
Well,
we
what
should.
sent it down for some reason was a command that should have told the kernel to ignore that drive. And for some reason, it just, I mean, I don't know what they did to fix it. Did they just cycle power? It's probably what they did.
I don't know. I had no. Yeah, I try to. We've lost the 888 on K9Q KPH2, and I tried. I can remotely power cycle it. It still doesn't. That's the one. We don't, how many are missing in the FFT log there?
Well, it's not very long. I mean, it's doing them now. I'm
Yeah,
not running KNIQ Web there yet, so it won't have a long list like the others. It's a cert
yeah,
file, 251 bytes in that file, FFT log.
yeah. I saw that
I
was
don't
pretty.
actually have to run it through sort unique. It's just, if it's the size it already has, FFT gen will finish right away.
Yeah, yeah. Well, that's what I do when you include me into that. That's what Whisper Demon does. I run the list, right? I have an array of all of uh, the plans that I knew were used for any spectrum, zoom
Yeah, but
level.
that's the hard way. I just let it build a
Okay, but
list of the ones it actually
okay.
uses and then create them.
Well, that's the thing is that people's. I mean, I run through all the zoom levels, so I figure
Yeah,
out
see
how.
how it just went right through the
Yeah,
1296 one because that
yeah,
was already in there.
yeah. Well, but that's true for the FFT Wisdom program as well.
Yeah, if I do it
It
again,
Yeah, it'll just run right through it.
see,
Yeah,
like that,
yeah,
right?
yeah, yeah. Well, when you include me that in, I just put it in. So Whisper Demon runs it FFT W Wisdom every startup, and it doesn't. Most of the time it takes a half a second. It just tells you it's
Yeah,
got them all.
might as well restart it since I now have new wisdom here. Most
Yeah.
of the applications seem to be pretty good at dealing with radio D restarts these days,
I
from
have
what
no
I've
trouble
seen.
with that. Yeah.
Well, they actually appear as new sessions because the source port usually changes. So it'll appear as a new session to the same SSRC.
Well,
And PCM
I think
record will typically close the file and open a new one if it's recording to a file.
yeah, that's yeah, and WD record works the same way.
Yeah.
So
When I do this, usually I lose only one cycle of decoding. I
Yeah.
actually tried to make it so I wouldn't lose anything, but I usually lose one 15-second cycle.
Yeah. Well, I had the
Not too
same.
bad. So everything here seems to be working too.
Yeah, it doesn't look like you're doing any. Whisper Demon's running, so I guess
Yeah.
there's.
Let's see what it's hearing. This was bad the other day. I mean, both it and VY0 ERC were hearing almost nothing because the KP index hit about 7, like
Yeah.
twice over the last 2 days.
Yeah.
It's more normal now. So as you can see, when the conditions are good, polar propagation is pretty interesting. Oh, there's somebody working or calling Sable Island, CY0S. Heard
Mm.
that too.
Mm.
Right now, there's a gray line covering both poles.
Yeah.
So this is the time of year they should be able to work each other.
Well, is VY0 hearing the
It occasionally hears.
well, because the transmitter's running there, the whisper sound is
Yeah.
running at DP0. We
Well,
don't.
let's see. Actually, it's
And actually,
whisper. This is FT8. Let me see. Is there a whisper log?
yeah, there's a whisper log there. You can grab for it.
Yeah. Okay.
Yeah, grab
It's
for
what's the cost of just DP0? I mean,
VY0. Just put VY0, and that's
yeah.
enough.
Ag is a problem now.
Yeah, not there. No. That's
Well, log might have gotten rotated. Yeah, in
yeah.
fact, it did. Log gets rotated once a day. Well, it's hearing itself, which actually is an important test. I like seeing that because when the band is closed, I have no other way easily telling that the thing is working.
Yeah. Well,
let's see. I can look for. Oh yeah, we got lots of C grep Y0. Let's try that. No, I didn't see it in any of them. Oh well.
Yeah. Oh well.
Well, it's been down for a while. As you can see, there's a gap here.
I don't know if VY0 is operational. I haven't looked for a while.
Yeah. I don't know.
There's a whisper sound up there, but I
Well, I
don't
can
know
go
that
there and take a look. Hey, it's cool. It's a few keystrokes I can like move from one pole to the other of the planet. Is this working? No, I don't see anything there. Um,
Let's see. ERC, it's the last 24 hours.
Sometimes demons have trouble with log rotation because the file gets truncated out from under them. If you always append to the file, there shouldn't be a problem.
Let's
try this. Oh, POL, that's their ship, right? Well, okay, it's hearing it. Here we go. On March 8th, March 3rd, and February 27th, it heard DP0GVN.
Okay, well, you got
on 20 meters, 17 meters, and 15 meters.
Okay.
Now let's see, where's JH14? Well, that's where the ship is now. Let's see, JH. Obviously, it's in the Arctic, not the Antarctic. I think, or is it?
IB. It's that's.
Well, IB59 is close to Antarctica. What is JG39?
I don't know.
The first one is longitude, or I can never remember.
Well, the first one is the first two are the first one is latitude, and the second one is the longitude within. Yeah, so yeah,
okay.
CN is north of CM. So,
okay.
So B is pretty far south in whatever I is.
Okay. Let's see if these guys are on FT8. They were really active for a while. Yeah. There are a lot of they were doing a lot of FT8. And I told you a couple months ago they were calling CQ and FT8 on 80 and 160 constantly for hours. keying up for 15 seconds, going off, keying up, and that was just wrecking the hell out of my AGC. And so I had to rewrite it. It's much better now. It adapts much more quickly to changing noise levels. Does more averaging over frequency and less over time. Where is it, by the way? I was looking at the Google Earth image. There's a Google Earth image of that site, and you can see structures, smaller structures around the main habitat. Do you know what direction it is? He said it's about 1.5 kilometers away.
Yes, kilometer and a half away, but I don't
You don't know
the
what direction?
No, I don't.
Hey, that would be
I
fun.
think
Let's see if we
I
can...
thought it would be away from the ocean right there.
Yeah, well, they're on the ice shelf. But hey, that
Yeah,
would be fun. Let's see if we can geolocate it by timing, by timing of arrival. That'd be a good test.
yeah, that would be. I don't know. But we're not going to get a time sync injector down there for a while, so we'll have to use Michael's, not Michael's approach.
Yeah. Well, I mean, we have a GPS controlled clock, so at least we have correct frequency.
We have the correct we got correct frequency, but
Yeah.
we need time of arrival. We can get within a millisecond, I think.
Well, that's millisecond is 300 kilometers. Right?
Yeah, well, that's true. Millisecond is.
So let's see. What is
Guys,
what is it using for a GPSDO?
I
Up there.
think it's a Bogner.
Yeah, I don't see it on this bus. It must be powered separately.
It could be powered separately. Yeah,
I know it's visible down here. Because I just noticed that it was. See, Leo Bodnar is on the bus here. So.
Yeah. Well, I encourage people to put their Bogner onto the same machine as the 888.
Yeah. I've installed Cronny on all of the machines I manage. It seems to be the latest and greatest NTP client.
Yeah.
A bunch of them were not running NTP. Well, they were defaulting to the one that's in System D. System D seems to provide like low quality replacements for many of the standard system services. And it was not setting the offset between GPS, between UTC and TAI, which is why you were getting that message sometimes about an unknown offset.
Yeah, I've noticed that, so I've been installing Cronny. Do you
Yeah,
have to? I think all you have to do is to apt install Cronny, right? That's it.
Yeah, well, Cronny or NTP, actually, either one will do it.
And it's
the one that's in System D will not. Okay, it looks like they've got a local NTP server down there because I asked about that. They've got a local NTP server, and as you can see, it's a lot closer than the ones over the internet.
Yeah.
It still talks to them anyway, just in case this one goes nuts, but
yeah,
it should have good time. The same up here, I think.
Is there any are there any plans with the Daisy 2 systems to somehow slave the GPS to the Cronny or NTP?
Well, in order to do that right, you would need a 1 PPS from the GPS directly in PC.
Yeah, and
I mean,
well, then
ways of doing that.
You can do it, but you need an input on the server.
Yeah, the classic way of doing it was to wire the 1 PPS to like one of the modem control pins on an RS-232 connector. And that was great when they had actual RS-232 with interfaces, but now they're all USB dongles. So now you have the propagation delay or the whatever the latency is in the USB subsystem delaying that pulse.
Right.
But NTP is rarely good, better do it in a few milliseconds anyway. So let's see. It looks like they do not. That's right. I was asking Pierre, I think, whether or not they had a local NTP server up there in Canada, and he said they had one, but it would require some network work to be able for me to get to it. So it looks like it's.
Remember that we ran that whole thing with their networking problems between.
Yeah, because this is going over Wi-Fi over Starlink.
It's going to, yeah, what
Yeah.
many stars.
Actually, not bad. I mean, this is actually not bad propagation times compared to Antarctica, which is greater because it's going over more hops to get there. With the exception of, the local clock that's actually being used, that's only
Yeah.
4.3 milliseconds away. But
Well,
VY0ELC is relying on the outside NTP world.
well, that's within Canada.
Yeah. So you can see the kinds of, this is the kind of variance you get when you have to do that. So your timestamps aren't going to be much more reliable than this.
Is that okay? So the last columns are
It's the error estimate in the round trip delay to the that particular server. It
We've
assumes
got
that the
one of
round
the
trip. Hmm?
we've got a dual output Modnar at the WWV2 site,
Yeah.
and the newer ones will do pulse per second over USB, and I've configured that.
Yeah.
And looking at Chrony sources on it right now, the Bodnar shows plus or minus 44 microseconds.
Well, that's its variance. It might be consistently off, but only plus or minus 44 microseconds from whatever the bias is, right? I think this is measuring the variance, the dispersion of the round trip time.
Yeah, and I'm looking at the internet sources, and the best internet source is 19 milliseconds.
Yeah. Well, that's the round trip time down to the, and that's always going to have more variance. But variance is not the same thing as mean, right? I mean, they're different numbers. So it'd be an interesting experiment when we get the 1 PPS time code in place to compare it against all these other sources and see what really is the most stable and accurate.
Do you look at Chrony source stats as well?
Yeah, that's what this is. Chrony sources.
Source stats.
Oh, source stats. Is that
One
source
word.
stats?
Yes.
Yeah. Oh, okay. I didn't know about that.
At WWV2 right now, the Bodnar pulse per second over USB is showing it just went to 104 nanosecond offset and a 253 microsecond standard deviation.
Offset. I don't know how it will compute an offset, though. Well, maybe it can. Maybe it's able to time the delay through the USB subsystem to go out and come back from the device. That could be.
I think that's the delay of the individual server to the ensemble time.
Okay.
In other words, after it calculates the actual time, it says, okay, all my sources, what were they off by?
Yeah.
I suspect because it moves around.
Off by compared to why? You always have to have a better clock as a reference. Even GPS has this problem. If you have a long antenna lead, your 1 pulse per second is going to be delayed because it has no way of knowing how long that antenna cable is. Everything is delayed by
U-blocks, you tell it.
What?
On the
You tell it.
U-blocks.
Yeah, you have to tell it how long the lead line is.
I don't know if the Bodnar does that or not. It might.
I don't think so. It probably isn't considered that important.
Yeah.
This is primarily a frequency reference, not a timing reference. But I remember that Qualcomm early on, the timing receivers they got had those adjustments, and you had to tell it just how long your feed line was and what the velocity factor was.
Yeah.
So everything seems to be running smoothly again.
Well, my point with the Bodnar pulse per second is at least then, you've got a semi-accurate time source, even if your internet time is crap.
Yeah, that's true. That's true. NTP is surprisingly reliable. If you have any connection at all, it's going to find somebody who's going to get approximately the right time. At least your file modification times won't be totally wrong. That's what it's mainly for. And that doesn't require a whole lot of precision.
So the way that I have the systems configured is that, so I use hardware serial ports.
Yeah.
This is a serial port card.
That's the first two lines.
Yeah.
Yeah.
Yeah. So the second line, the pulse per second, that's the pulse per second coming off or from the U-Blocks receiver on the DCD pin.
Oh, that's considered separate from the first line?
Yeah, so the first line is
Oh, that's from the one that's from the nav message.
yes,
So it's always
yes,
going to be off by a significant chunk because of the
yes.
that's what
Uh-huh.
the 244 comes from.
Yeah,
All right.
yeah.
That's why it's
That's
got an
why,
X in front of it.
Huh?
yeah,
That's what the X is. It's a false ticker. It's being
I
rejected.
see. Yeah.
yeah,
Yeah.
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 Because so the the main idea is that if the system did not have internet access, it would at least get um, time from the GPS nav
Oh,
message.
sure. Oh, sure. Having a local GPS receiver is always good
Yeah,
if you can use
yeah.
it.
And
Sure.
this is how I have this is how that I'm going to have all mine set up. But yeah, this is so this is what I use, and the thin clients that I'm using, the specific model has either a built-in serial port or options for a serial port,
Okay.
which is handy. Oh, and to answer the question from before, this is a plot of the sound card sample rate throughout the day.
Yeah.
So it varies about 1 hertz.
Oh, okay. Well, it fades off. It looks like a little less than a millisecond, plus or minus.
Yeah.
Well, actually, a little better than that.
Mm-hmm.
Interesting is
Yeah.
biased upwards.
Yeah.
Slightly biased to positive, yeah. Um, okay. It's
Yeah.
probably not unexpected for a
Right.
very
Yeah.
crystal,
Mm-hmm.
yeah. Not a
Yeah. Yeah.
okay.
And so this is using the Behringer
Oh, here's
404.
yeah, I wanted to show you this. This is my machine at home. I have an NTP. I have a Time Machines NTP standalone NTP server sitting on my network, so you can see what it's doing here. It is a separate machine, just like the one in Antarctica, and it's standard deviation 309 microseconds. It's not bad.
Yeah.
It's a bit of a, I mean, I don't really need it, but it's nice to have. The hard part was finding a place for the GPS antenna. I mean, I already have a GPS antenna in the shack, but I've been trying to get stuff out of there that generates noise. So anything that doesn't have to be there, I'm trying to put somewhere else in the house.
How are you feeding that? Is that a
It's a standalone box. You just put a GPS antenna, power, and a network connection on it. It comes up and it starts serving NTP.
Oh, okay, okay.
It's very old. I've had it, I don't know, 10, 15 years. It still works. I bricked it once, had to send it back. They reflashed it. It's worked fine ever since.
Oh, is it like a Symmetricom?
It's not Symmetricom. It's what's that company? Time Machines? I call it Time Machine, but forgetting now exactly what it is. I'll look for that.
Okay. Yeah, they're um
Is it these guys? Let's see. I think it's these guys.
Time
Here,
machines in
yeah.
Nebraska.
Let me share again. Share. There we go. I think this is it. I think it's these guys. They may not sell it
oh,
anymore. These guys products. I think
you're right. Yep. Yep.
it was this one. Yeah, that's the one I have.
Okay.
It's a bit pricey for what it is, but it was really easy, really easy and simple. I didn't pay that much for it. It's been a while. But
Yeah.
it's very simple. It doesn't have a
Yeah.
one TPS. It just serves NTP over the Ethernet. So I just put it in as another time source in my local network, and if it's up, everybody uses it. If not, they fall back to the ones on the outside network.
Right. Yeah. Yeah. The the way that I have the VLF systems configured is that since they have a GPS attached to them directly, I set it up so it can serve time as well locally. Well, locally anyway, on the LAN, but
Well, if they've got the hardware needed to do it, why not?
yeah, yeah. Um, but so Paul helped me out with the design of that board. Um, so it outputs a pulse per second signal through a potentiometer to adjust the level. Then that goes into the sound card, and then it also the UART from the U blocks that connects to an RS-232 transceiver along with the pulse per second. So it's a simple interface, but for the VLS systems, it actually works quite well.
Yeah, good.
But,
Have you guys actually seen KNIQ Web recently? You play with it? Here's it looks like now.
Not recently, but I have.
Yeah, this is KFS Omni. This is Wayne's latest code. Even up there's an awful lot of noise, but it's nowhere near as bad as in my place. And I got crap all over the neighborhood. Probably my ham shack. See what's happening on 60 meters. I'd never seen 60 meters I'd never seen 60 meters so busy as I did during the Bouvet Island, the expedition, when they were working FT8 there. Yeah, that's typical. FT8 in the middle channel and like nothing on the others. Now, I've been doing a lot of work with FFT windows and averaging and such. So we have two different ways of averaging. This is averaging inside of Radio D, and this is averaging inside of the browser. And they work a little differently. Wayne and I are trying to decide which one to keep, if not both. The main thing it does is smooth out the noise estimate. You can tell it's FT8. Yeah, it's starting to look pretty nice. Look at these radars, these CODARs. These things have got to be good signals of opportunity for doing HF propagation research. They're all over the place.
Is there a way to interface an IQ output or the IQ output of Radio D into GNU radio?
Sure. Well, actually, I had a talk at the conference in Connecticut. I had a talk with who's the guy who does the packaging for
radio
cable.
content.
The guy who packages radio does the Debian packaging. What was his name?
Oh, is it Maitland?
Yeah, Maitland Bottoms. Is that his name? Yeah.
Yeah.
I talked to him and I told him how important that was, and that there was an out of tree module to do just that, and that I thought that was like really crucial. And he would look at that and try to make it a formally supported in-tree module. I told him it didn't have to really do anything with the metadata. I mean, it could be all manual, but there needs to be some way of terminating an RTP stream, mono or stereo, and making it a source block in GNU Radio. I mean, that'll enable a lot of things.
Yeah, because Nathaniel, one of his, well, other than Whisper Demon and the timing beacons,
The third uh, experiment or observation that he does is are these radars, and he runs chirp sounder, and he wanted to run chirp sounder with one of these systems.
Certainly could. I mean, depending on how wide it is, one of these, I mean, you could just make it a wide KNIQ radio channel and then do all the processing at baseband. But if you want to follow an ionosound, that's a different story. You know, I'd have to build a channel that could actually track it for you. You sure see enough of those. This is a weird, I don't know, is there two of them? There must be two of them in here that are synchronized. And different frequencies.
Because I guess the chirp sounder software would produce ionograms
over a limited frequency range, I guess.
Yeah, but I don't know what input that it takes, whether it takes the full bandwidth of the input, or if it's different channels. I
Well,
don't.
it can kind of give you whatever you want. I mean, the down converter gives you something that looks just like a tuner on a front end on an antenna.
Yeah,
It's kind of, you know, let's see, that's all the fun and games. I've put in so many of these windows to play with. Here's a rectangular window. That's how the peaks got sharper, but the side lobes are worse. And this is probably one of the, I don't know, roll things out. Actually, good one all around is probably the Hahn window. That's just a half sinusoid or raised cosine. It's one of the simplest windows.
that's all the Hahn window is.
A Hahn window is just a raised cosine, yeah. And the Hamming window is almost the same thing, except it's shifted slightly. And that's done so that it puts a notch where like the second side lobe is, I think. However, the drop-off rate is slower.
Okay.
The ultimate attenuation is a function of how many derivatives are continuous of the wave of the window. So if the window does not go to zero at the edges, then you're never going to do better than 6 dB per octave, I think, ultimate. Although it may start very low, like the Kaiser window is like that. The Kaiser window doesn't actually go to zero, but if you use a large enough beta value, the side lobes start at like minus 100 dB, right? So the fact that they only drop an additional 6 dB per octave past that is not much of a problem. That's the one I use for my internal filters. Whenever you set a filter bandwidth, that filter is generated using a Kaiser window. I take a complex sinusoid, shift it, and then window it. So it shifts in frequency, and then that becomes my my impulse response. And you can vary that. It's one of the parameters you can vary, but I let it default to 11, which is a high number, which pushes the side lobes down to about minus 100 or so.
Oh, really?
Yeah, about that. Yeah.
Oh, okay.
Yeah, there's some rules of thumb for the Kaiser window. You take the beta value and you can calculate what both the main lobe width and the attenuation of the side lobes are. And of course, they're a trade-off, right? I mean, you can't have a narrow main lobe and low side lobes at the same time. That uncertainty principle says you can't do that.
Right.
It's one or the other. So that's why I provide all these different windows and tweaks to play with. Go down to like the AM broadcast band. I think this antenna lets in the AM broadcast band. Let's see. That's a good place to, looks like they've got it mostly filtered here. Normally, my place, the AM broadcast band, has the strongest signals around. So you see more near the top, it looks like. Let's try this one. Zoom in. Because they're usually pretty stable propagation-wise. So Here we go. That's a 1 hertz bin. So, and I'm averaging over 7. So I have an averaging window. You take 7 of these Han windows end to end and let the signal ripple through them and then sum up the periodogram. That's why it looks like it's kind of wavy, because the signal is going down 1 second per, right? And so any transient is going to go rippling down this window, this series of 7 1 second windows until it falls off the end. So you can see that there is a high pass filter on the audio here. You can also see there's more than one station on this frequency. You can see at least 3 different carriers. And it turns out the AMDXers, this is how they identify their stations, because these carrier offsets are pretty predictable. But if I now play with the window, okay, that's a Han window. Watch what happens if I go to rectangular. Let's start with rectangular. You see how it got the peak got very sharp, but now the side lobes are terrible, see? You see how the side lobes came way up? But that's what you get when you use no window at all. It's also why you're not seeing any waviness here, because the window is flat. You don't get that kind of effect with a flat rectangular window. But if I go to, let's see, let me try Kaiser, because it has a Kaiser with a beta value of 0 is a rectangular window. It's identical, but as you increase the number, let's see, go to about 4. See, it knocked down the side lobes, but it made the main lobe a little bit fatter, see? And if I go higher, let's go up to a 7 or so. See, more of the same. See, you push the side lobes down, but the main lobe is now a little wider still, see? And we go up to 11. Yeah, turn it up to 11. See, you see how it got a little bit wider? But the side lobes are now below the noise. So you basically don't have to worry about them anymore. But this is this is the real challenge for Windows, is when you have several sinusoids close together like this, and you're trying to see each one individually. That can be a problem. You may have to try several different windows before you find one that really shows you what you want. See, that one only shows 2 carriers. You know there's at least 3. Kaiser. Kaiser is nice because it has a tweak. See, now you can see there's at least 3 carriers in there. See?
Yeah.
And then if I go down, let's try this and see if I see any more. Let's see. I think I see just 3. Let's go down a little more. Yeah, still 3. But you can see the side lobe starting to come up now, especially on the low side. It's not centered in the bin, which is why it's asymmetric. Yeah. So yeah, there's no such thing as a perfect ideal window for all uses. There's the Han window again. And if I do the Kaiser, let me do the Hamming window. It's got you can see a little notch right here, because it puts an extra notch in like the second side lobe, but then it doesn't fall off as fast as the Han window because of that discontinuity at the ends of the window. I don't know, with signal processing. I see a little bit of hum in the signal, not much. This one is super wide. The HP 5-point flat top, 5-term flat top. It's super wide, but it's the one you use when you actually want to measure the amplitude at the center of the signal. It's deliberately made broad over like a couple bins so that it is flat at the top, and it doesn't matter what the exact frequency is. Otherwise, you can have what's called a scalping effect, scalping loss, and may cause you to misread the amplitude. That's just for measuring signal amplitudes. So. usually use Kaiser around 5 or so a good compromise for this. You can also control the amount of overlap. When you're doing long, slow windows like this, you can overlap the windows so that the averaging isn't too extreme over time, but you still get the effects of suppressing variance of the noise. Anyway, I got a flight at 6 a.m. I think I should pack and get out of here. Anyway, nobody has anything else.
Yeah. This looks good.
Yeah,
Yeah,
go ahead and play with it. Bang on it. If you see any problems, let me know.
At least for the VLF signal processing, I'm going to stick with VLFRX tools. But this was interesting. I just wanted to kind of see the capabilities and what was out there and all that stuff.
There's no reason why we couldn't feed one of your front ends into KNIQ radio and use it just as you would any other front end, except that it can actually go down to 0 and show some usable signals down there.
Yeah.
Could do
Yeah.
it. I mean, it'll work. You could, put it through KNIQ web, and you can look at it just like we did the signals just now. We can go all the way down to 0.
Yeah.
I don't know how quiet the KFS locations are for VLF. Probably better than most. Where the site is. It's right almost on the coast. I mean, close enough that salt air is a problem. And it's in a large open field. There are houses nearby, but it's a lot less than a suburban subdevelopment.
That would be a good location for a VLF receiver.
Yeah. Oh, another location I've been meaning to mention that I've been working on is the Hat Creek Radio Observatory, Northern California, where the Allen Telescope Array is. So it's a semi-quiet zone. It's rural. I mean, it's surrounded by farmland. They try to keep the RF noise down there as low as they can. And I'm putting up a VHF UHF KNIQ radio receiver, and I want to put up one on HF as well. I think they're putting in a radio Jove, I think it is, radiometer, HF radiometer. If I can just tap on that antenna, that might be interesting because it should be a quiet site. And it would probably also be a good site for a magnetometer.
Mm-hmm. Yeah.
They have a fairly large chunk of land there, and they have fiber running all over the place for EMI reasons. So, one of the remote huts, so you could put one of those, bear one of those magnetometers.
Yeah.
They've got reference loss. They got 10 megahertz, 1 PPS, Ethernet, everything you want. I go up there every so often. If I had hardware, I could install it if I had enough time.
Well, very soon, I'm gonna be starting beta testing, and
Okay.
I would love to get some hardware to people who do have access to these quiet sites.
Yeah. I mean, I don't get it regularly. It's quite a ways away from me. It's at the other end of California, but I do go there, and I think they would be happy to host one.
Yeah.
I mean, it's a science. They do sciencey things there, so it's science, and they'd probably be happy to do it.
Okay. Well, then in that case, I will keep you in mind, and I'll let you know when things are ready.
Yeah, I'll cover the cost. I don't have a problem with that. I would just have to, make arrangements to make sure that everything you need, power and GPS or 1 PPA, whatever it is you need is available.
Would there be? Yeah. I'm sure there's an antenna splitter that we could split off the signal.
Oh, in what, VLF or for HF?
For GPS.
Oh yeah, yeah, but they do have 10 megahertz available. They distribute that everywhere, if that's useful, and a 1 PPS. I mean, it's a radio astronomy site, so that kind of stuff is kind of taken for granted. And the site I'm
Oh,
thinking
that's
of is
right.
a new one. They just got they got their 43rd dish. They had 42 for a long time. They got a 43rd, so they're joking now that the array is in its prime because 43 is a prime number. But anyway, they put it as far away from the other ones as they could to improve the baseline for interferometry. And so it's pretty remote from the building and all the rest of the electrical noise. And they just put a HUD in there with everything they need to support that antenna. So it seemed like some piggyback equipment might not be a bad idea. Might not be hard.
Yeah. Yeah, that'll be perfect.
Yeah. So I'll follow up on that and let you know.
Okay, excellent. Thanks, Phil.
Sure. And I should get out of here.
Yep, that's all I have. Thanks, guys.
Okay. See you all later.
See you.